Welcome students. Today we will learn some fundamentals of physics. Many students are asking about different types of fundamentals in physics. Also, we while writing anything in physics, we just do some silly mistakes because we have doubt in our fundamentals, or we have not cleared our fundamental. As a result, we write in a wrong manner, so that in future when we face the examination we lose our marks. So let us start, or let us clear some fundamentals, so that in future when you will read or when you will learn physics higher and higher in higher and higher classes, you will not face any fundamentals in physics. Okay, so first of all we'll see about physical quantity. I'm not going deep inside the matter, inside the content, because whatever is needed for class 9 and 10, only that much I will discuss, and if more you want to know, you may message me, I will tell in a different way. Okay, so what are the physical quantity? That means any quantity we use in physics, that is the physical quantity. Suppose mass, this is length, speed, like that. These all are known as, or these all are called as physical quantities. Now, these physical quantities, how or what are the different types of physical quantity? There are two types of physical quantities. Number one is fundamental quantity. Number two is derived quantity. One is fundamental quantity, the second is derived quantity. Fundamental quantity, which are basic, the initial, like mass, length, time. These three, more are there, you will read in 11 and 12 class, but here you will read three. So mass and length and time, these are fundamental quantities, which are basic quantities. We cannot derive anything, these three quantity from any quantity. And derived quantity are the quantities, those are derived from this, like speed, velocity, force, like that. These are the derived quantity. Now, how can we express the physical quantities? This is the most important thing. How will express the physical quantities, or how will write the physical quantities? Suppose I will write force is equal to 2 Newton. Another thing I will write force is equal to 0.5 Newton. And force is equal to 15.15 Newton, like that. So how we will express, or how we will write the physical quantities? Remember, you have read also in mathematics in class 8 standardization. The physical quantities are written in the form of their order of magnitude. This is a new term, order of magnitude. So what is order of magnitude? Now each physical quantity can be written in the power of 10. That means every physical quantity will be expressed in the power of 10. And how? Now there will be a number, whole number, and in that number there should be one digit left to the decimal. We will not write 15.25 Newton. We will just write 1.525 into 10 to the power 1 Newton. This is the exact form of writing the physical quantities. Clear? That means each of the physical quantity will be expressed as the power of 10, and in this number, in the whole number or in the number, here there should be one digit left to the decimal, not 0. We cannot write 0 point something. We have to write a decimal, a whole number. Suppose 0.00125 meter per second. It is not the standard form. You will write 1.25 into 10 to the power 123 minus 3 meter per second. This is the standard form of writing the physical quantities. Next we will see the units. Same, two types of units: fundamental and derived. We can write the unit of fundamental quantities are fundamental units, the unit of derived quantities are derived units. Clear? Now we will see different system of unit. In CBSE we will use only two systems mainly. One is SI system, or we can say generalized form of SI system is MKS system, and that is another is CGS system. One is SI system, or we can say MKS system, and another is CGS system. Here M for meter, K for kilogram, S for second. These are the three fundamental quantities: mass, length and time. C for centimeter, G for gram, S for second. Clear? Now, how to write the units? We'll write the units. Many students or many people, they just write the units wrongly. Suppose I will write another thing, the unit Newton. This is the wrong way of writing. So just see, I am telling how to write the units. So there are two types of units. In one type, the units are written in the name of the scientist, like Newton, Coulomb, Joule, etc. etc. If the units are written in the name of the scientist, while writing the full form of a unit, the first letter should be small letter in every unit. While writing the full form of unit, if the unit will be written in full form, the total unit will be written in small letters. But if the unit will be in the name of any scientist, if we use the abbreviation or short form of the unit, we use the capital letter here, like Newton, N. But if we write kilogram, it is not in the name of any scientist. So we just write small letter kg. Clear? It is the most important thing. If the name, every unit in the full form will be written in small letter. If the units are in the name of the scientist, the short form will be written in capital letter. If the name of the unit or units are not in the name of the scientist, the units will be written in the short form in small letters. Clear? Okay. Now many students have asked me, Sir, write the difference between scalar and vector. Remember, scalar quantity is a quantity which has magnitude. Magnitude, but no direction. Scalar quantities does not, or quantities do not have any direction. Suppose speed of a body is 2 meters per second. In which direction it is 2 meters per second, we don't know. So it is a scalar quantity. But vector quantity, it has a magnitude. Magnitude means value plus a particular direction. So why I am writing here particular direction? Because if we consider the electric current here, electric current is a scalar quantity, although it has direction. How? The electric current, when we have read electric current, we have read that electric current is the flow of electrons, charges, and if we consider the electric circuit, the electrons flow from negative terminal to positive terminal in the circuit. But if we consider the potential theory, the electrons flow from positive terminal to negative terminal. So this is the contradictory statements. Electrons flow from negative to positive terminal, but electric current flow from positive to negative terminal. Both are two contradictory statements. Here the electric current has two directions. As the electric current has two directions, we cannot say electric current is a vector quantity. It is a scalar quantity. Clear? So scalar quantity is having magnitude plus direction, magnitude without direction. Vector quantity will have magnitude plus direction. Clear? So these are the fundamentals I had to tell to you, which will be little useful for your in your future while you will be reading physics in higher classes. In the next class, we will go to the contents of your class 9 and 10. Thank you everybody.